Hello and welcome to this rather epic rundown of creative quantizer patches for Eurorack with this demo of Ziggurat from Acid Rain Technology. Here's what's to come. This video is sponsored by Acid Rain Technology. So this is a big video with loads of examples, and if you'd like to skip straight to those examples, head to the time on screen and check the timing links in the video description. This is Ziggurat from Acid Rain Technology, and before I get into the features, I'd first like to address the kind of washed out, brighter, lighter grey look to the modules, specifically in this video. I use a lot of light when making these videos, and as Acid Rain Technology use these brushed finish panels, it's catching that light and reflecting it a lot. So outside of having blaring LED video lights here to produce the video on screen now is me filming this under the normal lights that I have here in my room with my phone to give you a better look at what this actually looks like in person. If you're new to quantizers, a quantizer takes an incoming voltage and adjusts it to match a set of musical notes. Whether that's all the chromatic notes, major or minor scales, or a custom set of notes, they adjust that incoming voltage to match the set notes on the note mask, and they do that either by detecting and adjusting any changing voltage at the input, or some quantizers can also do that when receiving a gate signal telling it when to update to a new note. Ziggurat is 14 HP and offers 4 channels of quantizing. And there's a nice smart simple interface here for applying deeper musical and creative features easily. On the top left we have our ins and outs, with 4 inputs, 4 gate inputs and 4 outputs. And there's a mod input that you can assign to do various things here too. And how you patch these inputs defines the overall mode that the quantizer channel is working within. CV only mode happens when you simply patch a CV input only. CV and gate mode is when you patch an input and a gate input, and that will update and hold a quantized note based on the input voltage only when it receives a gate signal at the gate input. And gate only mode there is when you patch a gate but no input, and that gate will then trigger a random value on that channel. Down this right hand side we have a keyboard set of keys laid sideways, which you can use to select which notes are available to quantize to, and they're also used to select values for the different parameters here. You have channel select buttons, labelled 1 through 4, and then these 8 buttons are for saving and loading or selecting various functions to set the quantizing. You can save or load the whole state of the module by pressing either save or load, and pressing save will then present you with your bank selection on what would be the black keys on this keyboard interface and the slot that you're saving to, on that right hand side what would be the white keys on that keyboard interface. And loading is the same, you would press load and choose a bank and a slot. And it's worth noting there is an autosave function that's always happening that we'll talk about later on. To understand the features, it's good to look at the signal flow in the module. And here's an image on screen from the Acid Rain website where we can see that the inputs are those different modes depending on how you patch them, as we mentioned earlier. And then your inputs will mix with any given offsets that you set up, and that gets quantized to the notes available in your note mask. That quantized voltage can then be slewed, which is a glide or sliding between the notes. You can adjust the range of output voltages, and this offers a creative note wrapping behavior that we'll get to later. And then all this mixes a bit like a precision adder with a root control, which offers post-quantizing, transposing, or you can creatively mix in external signals here into these quantized voltages. So with all that said, let's go through and highlight these features. If we press Slew, you can use your keyboard interface here to select which notes that a slew would apply to. So Slew doesn't have to apply to all the notes, it can be none of the notes, or just selected notes. And then holding Slew, these white keyboard keys are used to select one of 7 values for your slew time. Pressing Slew again leaves that setting, and then if we press Root, we have the keyboard interface here where we can mix and transpose with a root note voltage. Coming out of Root and pressing Offset, this again gives us this keyboard interface where you can add an offset. Offsets are pre-quantizer, so they will get quantized with the input, and Root is post-quantize, so that transpose is after quantizing has happened. And if you're in the root or the offset here, holding range will let you use these keys to come up and down in octaves, so you can go beyond just a single octave of that keyboard interface. Pressing range allows you to select the output range of that quantizer channel, and you select the channel here that you're applying things to, and that applies to all the different settings there. So you can see on this keyboard interface, we have a 0 marked, and you have to press 2 buttons here to select a range. You could press the same one twice, just to work within that single octave, or you can press a bottom note and a top note to create that range, or you could press a top note and a bottom note, and that goes from -4 octaves, so -4 volts, up to 7, plus 7 volts there. And that range is super smart as it doesn't just clip your voltages at the top and bottom ranges, it actually note wraps everything outside of those ranges back down or back up. So if you played the note F above the top of your range, it would fall back down to the bottom of the range, but still play the note F. Coming out of range, if you press chain here, you can select a series of notes and actually create a sequence. So it's like having a whole bonus step sequencer here, and you can go up to 32 steps, just adding buttons, adding steps and values. You can press the same value more than once, and pressing range, like in the other modes, will take you up and down in octaves, so you can span multiple octaves with your chains here. Once that chain's created, you'd then use a gate signal on that channel to step through that chain. And with all these settings, remember you could have a completely different setting across all those different channels too, or the same setting, or just one that's quite similar. And with that wide range of settings you can have at any time, there is an auto-save feature that's always auto-saving anything that you're doing. So if you turn off your system and turn it back on, it will restart exactly where you left it. And that's a completely separate autosave layer outside of any actual saving to banks and slots that you do manually. And then finally here we have that mentioned mod input, and you simply press the mod button and then choose a behavior to assign it. We could press mod and load, and that would let you use an external voltage, volt per octave to be specific, to load different save slots. You could press mod and slew to use an external voltage to modulate slew time. Mod and root would let you mix in external voltages to that channel, or whichever channels you choose to apply that to, or combinations of channels. That would then add a root note post-quantizer mix of the external signal to those channels. You could press mod and offset to add an offset before that quantizing happens. You can press mod and chain to use an external signal to reset that chain, and from that mod mode you could be in mod and range to use an external signal to move through various octave spans from a single octave to the range that you select. You can actually modulate that externally for those channels too. So I think I've covered everything. There's lots going on here and some really smart and creative features that's led to lots of really musical results. And with the range of features and examples here, I think Ziggurat is a good example of how, even if you say have plenty of quantized sequencing options or MIDI options, you can still use a quantizer here to offer lots of fun functions and plenty of use cases for a variety of setups. And it's worth noting again that while there's a lot going on feature-wise for the module, it's been really quite easy to navigate, and that's become really quick once I'd used it for a short while. So let's dive into this massive rundown with loads of patches that you can apply to many quantizers in Eurorack, but specifically we're of course using the features of Ziggurat here. The timing index has been on screen, so skip around as you like. And let's dive in. So here we're making melodies from LFOs. I have two different rates of triangle LFOs. They're unipolar and already attenuated to about 0 to 2 volts. The green trace here is my input to channel 1. The green LED cable shows the rate I'm triggering that quantizing to kind of sample and hold a new pitch value. And the output is the yellow trace, and that comes to the volt per octave of my first voice. The slower red trace there and red cables is the input to channel 3. The blue trace is the rate that's been triggered by. At the moment they're just the same. And the blue cables there and blue trace is the output. And if I hard pan my voices here in stereo, even bring them into the same octave, there's my two voices from two LFOs. But let's just focus on one and explore what I think is a really beautiful relationship you can get into between the rate that you trigger this and the rate of the LFO coming in. So we're now just listening to the first voice, channel 1 here on Ziggurat, and you can hear we have a really musical sounding pattern happening. Kind of got this low high thing going on. If I just slow down the input triangle LFO here while keeping the rate of triggering the same, we're going up and down like a triangle LFO, but at some kind of subharmonic frequency of what's coming in. Let's actually speed up the triangle LFO this time. So even though the rate of the LFO now is very fast, we've got a much slower rise and fall, and it's that relationship between the clocking frequency and the frequency of the LFO. I'll play around with the rate of the input again while keeping the trigger the same. And again we found ourselves with a really nice musical pattern. I'll keep the input the same this time, but change the rate that I'm clocking this, and you'll see that happen on this green LED cable. And as we get fast enough, we have a shape that very much follows the input. But I'll slow down slightly here and let's see how it then starts to evolve. Again, it's easy to find nice musical patterns. Now if I mute this one and we listen to channel 3 here, my second voice instead, and I'll pan that one center. So let me speed up my LFOs, both of them here. Again, nice musical pattern there. Let's pan that hard right and bring in the first voice hard left in the mix. That one's now slowly rising and falling, even though we have a faster LFO at the input. If I start playing with the rhythms, and I don't just trigger this with a steady clock for both of them, we'll start to get some interesting melodic interplay too. with LFO shape, the rate coming in, and the rhythms that you trigger with, whether it's one melody or 4 even here on Ziggurat, you can pull a lot of melody out of your modulation. So here's Ripsaw that we're going to use as a chord oscillator into the black and blue stereo filter. I have an external keyboard that I'll overlay in the video edit, and the Voltproctive output from that keyboard goes into a buffered mult and copies 4 times across to the 4 inputs of the 4 channels here. They then output as the 4 Voltproctive signals into Ripsaw. And we can start to use the onboard offset to offset channels pre-quantizing. And you can do that by selecting notes on the keyboards. It's really musical. Say if I wanted a -7 chord here, just turn up the filter slightly. I'm going to leave the first channel as is. If I come to channel 2, press the offset, I can just select another key. And regardless of what buttons I press, it does stick to that key setting that you've set up for that channel. So if I offset here by a minor third, so I have C, offset still flashing, I'm in offset mode here, C, upper minor third is E flat, and then a G, and then on that 4th channel, a B flat. And if I start to play my keyboard here, they'll go into all the channels, and it's then being offset per channel to create those intervals. I'm just walking up that natural minor scale and back down again here, playing the same notes as the ones that are actually selected. But something really interesting happens here, and I'm finding this quite fascinating. If I go to, say, the 2nd channel here, as I come up to, say, D and then E flat, notice it doesn't change. You can hear one note changes, it's not that 2nd channel. The first one does, we can go from a D to an E flat. We can't go from a B flat to a B up a semitone. So some channels are hanging around because I'm only moving a semitone, but there isn't a semitone above to actually get to in the quantizing. And the output there on channel 4 won't move. So that's the sound of E flat if I play an E flat going up to it. If I come down from the F above, we get a different sound. And that's because, again, if we look at that F to E flat movement, which you can see with no offset there on channel 1, that's a tone, which means 2 potential steps there. We only come down a semitone on channel 2 there, doesn't move a full tone because there isn't the F sharp to jump to, it's not turned on as a potential note here. That just moves a semitone, but again, if I go down to D, we get different notes. So as I play up and down that scale again, listen to how it's different on the way up to on the way down. Super musical, some notes hang well, others change, so it's not like a block chord thing, it's kind of interweaving, some steps holding and going up. And one last thing before we set this in a kind of musical situation here, when you have the offset on, you can hold range, and just like selecting a range for the actual note mask, you can move up and down in octaves too, so you're not restricted to only offsetting within the octave that you can see there on the keyboard style interface. So if I go to channel 2, that's up a minor third from C to E flat. But if I hold range, I can move that up and down in octaves. Let's open up the filter here. say go to our root note and come down an octave. So you can play around with octave spreads as well, not just a single octave of information there. So here's a really fun chord patch which is taking a single sequence, using the onboard offsets to create 4 pitch CVs to create chords, and using an additional sequence as a mod input that I can be playful with here. Modulating these chords with additional offset. And in this case using that to create a bass line that sits under the chords, all from Ziggurat. I'll play around for a moment just because I'm really enjoying the sound of this, and then we'll get into how this is set to create these chords and the bass line. The chords here, which is how this patch started, is like the previous example. It's the same volt-proctive signal, this green trace here, that's split in a buffered mult and coming in as my inputs. I'm using the offset, simply pressing offset and then selecting a note to offset. So for channel 1 there's no offset, there's none on channel 2, 3 goes up a fifth, and 4 goes up a minor third. But where we're in offset, indicated by it flashing there, holding range, we can shift the octaves. And I've just shifted the minor third on channel 4 up an octave, and I've shifted channel 1 down an octave. So we kind of have bass here, an octave lower, an octave, a fifth, and then the minor third above that. And that plays the volt-proctives here into ripsaw. But the fun bit is actually then using the mod inputs here, yellow trace and yellow cables, with another sequence to kind of add a bit of a moving bass line. If I go into mod, coming out of offset first, pressing channel 1, you can see mod is set to be an offset. So that's offsetting before it quantizes via this other sequence. If I turn that on for all channels, you can hear it jumping around, primarily in octaves. I don't think it sounds great across all of the chords there. If I just do that on, say, the root note and the sub-octave or octave lower bass in the chord, let's just leave that on the first channel there. And I'm using that with a split to create my bass as well. So if I actually mute the chords, this is then just plats. If I turn off that mod, I'm using a split there in a mult from that first output to feed the volt-proctive from plats, so it takes the root note from the chord. And if I either go into that offset, say again, channel 1, and I bring that back up an octave, you can hear that come up the octave as well. But let's leave it there, it's maybe a bit easier to hear what's going on. And again, going into mod, if I then enable that mod signal coming in just on channel 1, we can then hear the bass line. Coming out of mod, let's leave that on. We'll offset back down an octave. So we have a bass line and chords out of Ziggurat and 2 sequences. Super fun patch. Like a full breakdown of this, all the patching, all the kind of sound design, literally cable by cable, module by module, head to patreon.com/DivKid to get this as an exclusive video. So let's take a look at the note wrapping behaviour that we have control over with the range. I'm on channel 1 here, and to the right of the screen this slider will provide a +5 to -5 volt offset. That will be the blue trace on data, the red trace is 0 volts, and the yellow trace will be the quantized output. This channel is set to a minor pentatonic scale, and the range is the full -4 octaves to +7 octaves that we can do here. So as I simply move this fader up and down, we can hear that control an octave going through a big reverb just to soften down that really basic sound. Now if we go into range, you simply press 2 buttons here to set a range. You could set the bottom range in the top, or a top then a bottom, or double press the same one to give you your range. If I wanted just 1 octave, let's say from 0 volts, which is flashing to show it's selected, to 1 volt, just the button above is 1 octave above. Now when I move the control, you'll see and hear this yellow trace will hit that 1 volt peak, that 1 octave above, and anything that goes above wraps back round to the bottom of the range. So if I do a sweep from 0 to 5 volts here on this slider, you can see it just wraps back around within that octave. And likewise, anything that goes lower than the octave will wrap around to the top. So if I select, say, a slightly wider range here from 3 octaves above to an octave below, when this voltage gets lower, it will then jump back up to the top. So I'm moving below 0 volts now. So you can get these really interesting, and you can press 2 buttons kind of like this, or 1 and then the other, to set your range. So to show this with a moving source, let's actually patch in a -5 to +5 typical triangle LFO. So here's a typical -5 to +5 bipolar LFO signal, and even though I've set this to be the full potential range, that actually bottoms out at -4 octaves, -4 volts. So as it gets under 4 volts, right at the bottom of that triangle, you can see in here it peaks up to that top value. Now if I bring that down an octave, it's not wrapping up as high because it wraps to the top value. Let's come down an octave again. And down an octave again. So hopefully this is really highlighting that wrapping behaviour. It doesn't clip out at the top and bottom ranges here. It wraps any voltage that goes above the top to the bottom, and any voltage that goes below the bottom up to the top. If we set this lower, let's say 1 octave below and above 0, so a 2 volt range here, +1 to -1, you can see it continues to wrap around much faster. Let's go wider. So it's a very interesting, unique behaviour that's tricky to get kind of anywhere else without quite a bit of patching. It's much more musical than just clipping out the voltages. And if you didn't want this note wrapping behaviour, you could set this as wide as it will go, much wider than you want, and then attenuate your voltage first before coming in, and it won't have anything to wrap because your attenuated voltage will be within that potential range that you've set. And like everything else on the module, the range that you set here can be different on each channel, setting up different behaviours. You could even patch the same input across the channels with different ranges, and wrap into different octaves and create variations from a single source. So let's take a look at that note wrapping with the range control, with this bouncy, cheesy kind of retro trance lead. But before we do that, just one little trick here that I find really useful. If you need to pitch offset down or up, say, an octave, you can actually use the module to do that if you have spare channels. My sequence here comes in on channel 1. There's also some transposing going on just by going to mod, offset, and letting that apply to channel 1. That's the input just rolling round and round, which is the green trace. That's transposing with some external modulation from a second slower sequence. But I'm taking the output of channel 1 there, the modulated, transposed, quantized sequence, splitting it with a stacking cable into channel 2, and I'm using the offset and the octave offset to give me an octave down, and that's then going into the second volt per octave on ripsaw here, so I'm -1 volt or -1 octave offsetting my pitch information. We can see that if we go to channel 1 and offset and hold range, we're just at the default 0 offset there. But on channel 2, that's down an octave. We could go down another. Just handy. And I realise every patch where there's kind of one focus, there's usually a couple of extra things in the video. The Ziggurat proves to just be really useful for lots of things here. But what's actually going on in terms of the note wrapping, I have my range set here, as wide as it will go. And we just have our sequence. But if I then start to go in and lower the range here, let's say just across 2 octaves, you can hear we don't clip out at that upper voice, at that upper octave. It wraps those notes back round. And if we just stay in 1 octave, just pressing the same button twice here, and the notes that pass the top barrier, so in this case 2 octaves above, come down underneath. So if I lower the range, those higher notes will wrap around even lower as I've made a lower octave available. And that low down, you can hear it just kind of works as a rest. It's so low, it's not coming through the patch. Likewise, if we were to wrap the low notes, so make a range where the low notes come back up, they'll come up to the top of that range. So if I make the top range higher, those low notes that have been kind of choked out and wrapped up, they're going all the way up to the top of the range. So it's quite interesting, you can be quite playful here. Kind of on the fly performing and repurposing how spread out in terms of how many octaves your sequence is occupying. Going fully open here. This just passes as is. I know that particular range is enough octaves to play this whole pattern as well, but we can play around. And I'm double pressing if I just want a single octave, as you use the 2 presses here to set the top and bottom range. You might see me doing it more like a kind of double fingered or thumb and finger press. That works too. So here we'll explore using external voltages to control the range. And the range here is set to be a few octaves. I have a sequence coming in that's about 3 octaves of range here. It's the green trace. That's the input. And the blue trace is the output, which currently you can see just mirrors that input. Now, as we know, if we set that range smaller manually, let's say to just 1 octave, it's starts to wrap those notes back in. So if you had a G that was above the top of the range, it'll go to the G at the bottom of the range, as we've seen in the other examples. Now I'll keep this a bit wider here. Come out of range, press Mod, select range, and this is applying to channel 1 here. If I patch in an LFO here, I'll just turn it up in my external attenuator. This is a unipolar LFO, the red trace there going over the blue line, and the red cable into the mod. So again, this is pressing Mod, set to range, and affecting channel 1. If I unpatch an LFO that's coming in here, and just use a straight up voltage, how this works is 0 volts to 5 volts will take your range from a single octave, that bottom octave, all the way up to the full range that you've selected. So your range selection here does scale that incoming modulation as well, which is really handy. So if this down at 0 and mod set to control that range, it's just down in 1 octave. And as I raise this offset, you'll see this red line come up, see the blue sequence change, which is the quantizer's output. You'll hear it too, of course, and I'll just do that now off screen. So that's now spanning a wider range, again within the overall range I've already set. So it's a really fantastic way to take this 8-step sequence and with an external voltage here, change its range, note wrap back round into different octaves. So you could sequence your sequencing there, or sequence the range of sequencing really nicely. If I swap this back to a unipolar LFO, you can hear that range expand and then contract and compress down again. So when you don't actually patch an input to a quantizer channel, something really nice happens, which is inbuilt random voltages. Your trigger or gate triggers a new random voltage that's quantized to your quantizer settings, and quantized random and random in general is of course massively useful in a modular system. If I play with the rate that I'm triggering this here, and you'll see that on this LED cable, all the chromatic notes available there, we could say make this a major scale. We could just make this, say, a chord tone. Let's just say a simple C major, so C, E and G is available. And you could do that lovely thing that I'm going to do lots in the video of changing the notes and kind of playing the quantizer and back to C major there. You've got the range control, so if you're using this to say modulate something rather than using it for pitch or even just for pitch, if we hit that range button, you can go in and have a smaller range of outputting quantized random voltages, or a bigger one. And that's incredibly handy, so let's look at a couple of ideas of how you might like to use random voltages out of the Ziggurat. So setting this internal random in a musical context here, here's 2 voices where we get 2 volt per octave random pitches, and the other 2 random pitches are used for tonal modulation. So the first channel here, selecting channel 1, is set to be a minor pentatonic scale. That's triggered via 16th notes, and that green trace and cable provides the volt per octave for plats. The second channel just set chromatic because I'm not actually using it for pitch. I just want that nice quantized random voltage or random voltage. I'm triggering that via eighth notes. That's the blue trace, and it's modulating all of the tonal parameters on plats. So we have 16th note pitch changes and 8th note tonal changes, and that's just ticking away, plucked in my low pass gate here. And then the second voice is channel 3, and this has its own sequenced rhythm as the trigger. Again, no input, so we get the random voltage, and that's the red trace and cables providing pitch to the ripsaw into this foxtrot black and blue filter here. I'm then using another copy of my 8th note on this channel to give me tonal changes. That's the yellow cables and trace into the volt per octave of the filter. So if I make this really resonant, hopefully you'll hear we have faster, steady 8th note cut-off setting changes, where we have that slower, just 3-note rhythm per bar for my actual pitch. And that's it, nice and simple. Going through the ranges, you'll see that these are all set slightly differently depending on what I want to do here. So a nice small range for that bass line, but a slightly wider range for the plucky, arpeggiated type melody. And I'm playing the keyboard here, and it's really nice playing the chance of a note happening because we're triggering random rather than actually playing a note on a keyboard like a normal keyboard. So I can walk up the bottom notes in, say, a minor scale here. It will occasionally bounce around in octave still. So bringing both synth sounds back in, getting them side chaining against my kick drum. Let's bring the effects up. Good fun with just 4 triggered random voltages. So this patch I think is interesting for many reasons, all of which I'll go over, but the main focus here was to use a channel on Ziggurat set to just a single note so it can work just in octaves, choose the onboard random to get a random octave, and to use that patch back into itself via the mod input to randomly shift my main melody up and down in octaves. Now outside of the synth lines here, we have these basic bits of percussion, just kind of marking time a little bit. Let's mute those for now and start with our main sequence. So with this main sequence, one of the interesting points is that it's actually a mixture of 2 sequences. An 8-step sequence here from step 8 and a 5-step sequence here from Ozark. These 2 sources mix together and get attenuated, and that's the blue cable here into channel 1 as my input. This is just playing on kind of 16th notes on every note of my clock, and because these 2 sources, 8 steps against 5, just keep kind of evolving as those numbers don't resolve every bar, we have this kind of evolving melodic sequence. That's the blue trace here, and then using channel 2, the second thing I did was to set up a division of time which just happens every 8 steps. You can see that marked by this blue LED cable. It's coming from this sequencer here, just used like a divider. And if I go to channel 2, you can see the only note I have available is a C. So it's set to octaves. My first is just set to a major scale here, C major. And with that just set to C, if I go into mod, and this is genuinely the first time I've done anything with the mod, and before I used the manual, which I was going to go look at, I thought I'll just press mod and see what happens. And pressing mod that flashes to show it's selected, I can see it's set to offset, and I could see that these were all lit by default when I had them on. So I figured if I just turn them off other than the one I want, which was channel 1, that the mod will be an offset, because offset is lit, and it will affect the channels that are selected, which in this case is just channel 1. So it's the mark of a really good interface there that I could just press mod, see what it's doing, and assign that to a certain channel. Now on channel 2, that's the yellow trace here. It's set to 2 octaves of range. We could set that to just say 1 for now. And because there's no input on that channel, this is just randomly going to jump between these values, which again are just octaves. We could do say octaves and fifths. But I like just octaves here, so just leaving C selected. That randomly jumps up and down, as you can see on that yellow trace, and that comes back into the mod to octave shift the first input. Now going back to range, let's get this across 2 octaves. So 1 channel quantizing an 8-step and 5-step sequence mixed together, the second triggering random at a much slower rate there, and that random set to just be octaves in terms of available notes, and the modulation set to offset, just affecting the first channel, and I've patched it back into itself to octave shift. Quite cool, at least to me. And then on the 4th channel, I have this split cable here, splitting my main melody. And because that's kind of ever evolving, it doesn't come round every bar, like I said, triggering this from every 16 steps this time, or every 32 steps. When that lights up green, that quantizes this sequence and gives me a new bass line. And that's playing this sound in the patch. So it's exactly the same input material as that fast moving line. It's just triggered much, much slower. So together, I'm bringing those drums back in just for a bit of background flavour. So here we'll take a look at this slew, and this has a fantastic feature which is to select which notes have the slew applied to them. So if I press the slew, you're presented with the same keyboard interface. You can see grayed out the notes selected on your note mask that you've selected for available quantizing notes, and you simply turn them on and off to enable slew on that particular note. Now the green trace here is my incoming signal, my sequence. The blue trace is the output. I've scaled up the blue trace just so it's occupying more space there, hopefully to be clearer. See these curves and slews, those slides between the voltages. Now if I turn all of these on, it's just sliding around all over the place. And we simply hold the slew button to select the slew time. And while doing so, these buttons select our slew times. And as we go up from the bottom here, we have 50 milliseconds, 100 milliseconds, 300 milliseconds, and 750 milliseconds. And then 1.5, 3, and 5 seconds all the way up. So if I select a slower time here, or rather a faster time, hope you can hear this slight kink to the sound between those pitches. Maybe more obvious there on that second setting. Really obvious there as you get up to 300 milliseconds. And we can go in, as I say, and turn slew on per note. If I did just my root here, you can really reshape and change that sequence, which is controlling the pitch of plats here. That's quite cool, just that kind of slide up to that A sharp or B flat there. So here I'm using the onboard slew to create smooth, fluctuating random voltages. Like other random voltages you'll see in the video, this is gated or triggered per channel. I've used LED cables so you can see when that happens. There's no input, and the outputs here, the channels 1, green, 2 blue and 3 yellow, follow the cables and traces as to where they're going. The first two, green and blue, modulate the wavetable position of a chord, and then the chord inversion, the notes in the chord and which octaves they're in. Channel 3, the yellow trace, is then modulating the level of this sound in optomix here, this low pass gate. And ripsaws droning. It's a bit of a droning wide bass sound just to pin the chord down. But let me remove the slew and then we'll build this back up. So turning off the slew, you can hear this is now of course stepping. Let's look at this slew, and we'll start by doing the first channel here, pressing slew, and I'll turn on every note. I'm not in any scale, these are just tonal modulations. Let's do the same on channel 2, same on channel 3. Every note is on, every note will slew, and in that slew, holding it down, you can see I have a slightly different setting on the channels here. And you can really nicely see this fade between the notes that it's selecting. But as I say, they're not notes. These voltages are all used for modulation. So whether it's 5 seconds, 3 seconds, or that 1.5 seconds, that's a lot of slew to smooth out these random voltages that the gates are triggering. And here's that exact same patch that you just heard generating the smooth, fluctuating random voltages, but set in a kind of like dub techno context. So other than the drums here, this is that same sound if I fade up the low pass gate here, mixing that bass and the chord sound together into another low pass gate channel here on the optomix that I'm striking, and then have a rising envelope fading the sound up as well. That goes into my effects, and that's just set simply against some basic percussion. So it feels like we've got this kind of consistent bass. The filter open there. And then if I bring that level down slightly, turn up that Platt's chord. The level of that Platt sound, as in the previous patch, is modulated by one of the channels, the yellow trace here, as is the sound and the chord inversion. It's really nice, that steady rhythm and swell plucking this channel of the low pass gate, having that chord sound move and emerge, just fluctuating randomly but really smoothly with lots of slew added. High slew times again across those channels, 1.5, 3 and 5 seconds as I go across the channels there. And all notes are available as a random voltage on all channels. It's irrelevant what the notes are when they're just modulating things for the most part. So we can also use the mod inputs here to CV that slew time. Now when we do this, going into slew, you still apply which notes you want to slew. Let's say put all of the ones in my available scale notes here turned on. Instead of holding to select your different preset slew times here, you press mod, pick slew, so that simple mod assignment that we've seen for the other modulation options, and I have a voltage here from a sequencer that's controlling that slew time. If I actually change that voltage to just be a kind of constant offset voltage, and you'll see this change here on the scope with the yellow trace, I'm going to turn up a voltage source here. All the notes are going to slew, mod is set to slew, so I'll just turn that voltage up, watch the scope, and you'll hear it increase in slew time. And it's already too much slew there. Turning that back down from that silly kind of wonkiness. I'm going back to my sequence. I have some steps on a slower sequence with Slew, some of it all the way down. And you can be very specific then with an external CV when you want to slew something. Still pressing Slew to select which notes that applies to. I'll just stick to the E flat and the B flat here. And you can actually see that Slew. Watch C to E flat here. You can kind of see that glide happen across that keyboard interface. So not only can you select which notes Slew will apply to, set an internal time, but you can also modulate that Slew time too. So here we'll look at the root control. I have a sequence coming in, that is this green trace here. But the first thing to look at is that it's actually a 0 to 5 volt sequence. So on channel 1 here, if I press range and just open this back out, the green trace there is the input, the blue trace is the output. And 5 octaves of range is just pretty ridiculous for any kind of melody that I might want to use. So using the range here, we can actually fold those notes back. The range doesn't just clip the signal, and that means I don't need an attenuator for my external sequencer here, and that's a really nice thing. So I just wanted to highlight it again in this patch. On channel 1 here, as I said, this is the input, the green trace, and I've just selected C, E flat and G, the intervals for a minor chord, as my available notes. But if we use the root note here, just pressing root, we have the keyboard interface where we can transpose post quantizer, so this doesn't follow the note mask of available notes that we've set. You can then transpose on that keyboard interface. That's different to offset, which will offset pre-quantizer, so that mixes the input and the offset before it's quantized. And if I try and offset this, let's say by a semitone again, which when we do that with the root sounds like this. Doing that with offset, we get a really interesting musical change of that sequence, but it can't go outside those available notes. Whereas the root note can, as it happens post quantizing. It's quite nice to play this and just perform live transpositions. But we can do that with the mod input as well, and I have an external keyboard here with a volt per octave output, and that's coming into the mod input. So if we press mod, select root, and apply that to channel 1 here, anything that I add, and you'll see me press these keys, I'll overlay a video on screen here. Just like pressing root and doing it manually. And what's quite nice is you can see what I'm doing on the keyboard in this root menu. So again, if I press root, I can do this by myself, just manually. But staying in this menu and playing into the mod, which is set mod and root, I've chosen root as a type of modulation here, we can see this keyboard note flashing to show us that external modulated root note transposition. Now the other channels here, 2 and 3, I use triggered with no input as random sources, and I'm just using those as stepped random to modulate the tone and length of the note there on plats. So here's a simple example of vibrato effects and even FM overtone effects with the mod input and the root selection. My input is this green trace sequence, and the output there goes to ripsaw into this stereo filter with an envelope to it, and some effects afterwards. But the mod input, selecting mod and root there, and it applying to channel 1, is this blue trace LFO from this oscillator. It comes into a VCA first, after the scope and before the quantizer here, where it's attenuated twice, once to set a maximum signal level and the other to more easily dial in that behaviour. And that being the root, post-quantizing of this input sequence applies to the vault per octave and comes through and gives us vibrato, or if we actually turn this up in terms of frequency even higher, we can actually pass through audio FM effects, and they're then going to come through after this sequence and into the vault per octave of riffs, or the actual voice we're hearing. So you can hear those FM overtones there. Now if we were actually doing this for the FM overtones, or just for the modulation even, it might be nice to get the modulating oscillator tracking vault per octave too. So patching the vault per octave in to that oscillator, we can hear that nice wobbly effect, but up at Audiorate, we have a more consistent FM tone because our voice and our modulator are tracking the pitch. So another situation where this mod input used for root, where we add post-quantizing a signal to it, is for pitch envelopes. And where you might want vault per octave sequencing and pitch envelopes is in this pitched kind of hybrid kick drum bassline situation. Now if I mute that sound, here's everything in the background. I'll mute that for now, and this is the sound we're focusing on. If I remove the sequencing, you can just hear it like a kick drum. It is a basic kick drum patch. I have the sine wave from my basic analog oscillator here into a clipping VCA with an envelope to the VCA, and the yellow trace here is an envelope I'm mixing into the mod set to be root there and enabled for channel 1. So that envelope is passing through the vault per octave with any pitch sequencing into that oscillator. If I turn that off, it's just that basic low sine wave. And I have this sequence here, which is the green trace and cables. I'll plug that back in. And this is tuned low, so hopefully you can hear it with whatever you're listening on. But you can hear that's just like a bass line. Sequence in, sequence out. But adding that envelope on top, we get this hybrid kind of kick drum bass line happening. And that might suit what you're trying to do with your drum synthesis and bassline generation. So all the sounds back in. It's a nice simple quick example, but one I wanted to point out. So here I've patched up a behaviour with Ziggurat that kind of turns it into a shift register inspired thing, where we take a single sequence and create a musical canon of kind of time delayed offset melodies. If I mute 2 of my 3 voices here and we go down to just the main one, this is Platts, with some effects in the background that I'll leave there. But I have a single sequence, it's this green trace, that's the input to channel 1, and I'm kind of carving into that mainly with the same trigger rhythm that would generate, but on this first LED cable here, and generating a new melody, which is the blue trace. If you watch green and blue there, you see that they're largely the same, just occasionally different, because I'm triggering that information, kind of carving up the sequence. And that blue trace is voice 1 here, blue cable to the vault per octave there on Platts. But I'm taking a copy of that across to the second channel, and then I'm using a different trigger rhythm that's slightly delayed from the first one, or slightly different, but the steps come after the first one. If I bring that sound in, it will be panned hard left. that's the red trace. You can see there that that's offset in time. If you look at blue and red there on the scope, red cable there to its volt per octave. And it's like one sequence samples something, passes it down to the next, that will then sample it slightly later. There's that kind of shift register idea. And then the third voice takes this second channel, the red trace and cables, copies that across on a stacking cable, uses another kind of offset rhythm here, and that's the yellow trace, so time delayed again, and that sounds hard right in the mix. I'll bring that in now. So if you watch blue, red and yellow, you'll see this kind of diagonal offset down data here, where they're the same pattern, or very closely the same, only different there because of trigger rhythms that are slightly different. But they're diagonally offset in time, giving a kind of shift register behaviour. Now I could use different rhythms, say on that extra voice there. And be quite playful, but we've still got this kind of channel handing off to the next one. As I say, kind of shift register behaviour. I could go into the offset there and say change the range. Let's say take that last channel down an octave. And then anything I do to that incoming signal, that kind of first sequence there, will then pass down across all the channels. And now changing up the sequence altogether. So hopefully that gets the idea across. A single sequence, which is my green trace as the input. I'm carving into that with a particular trigger rhythm that outputs to my first voice but passes to the next channel. A different rhythm from a trigger input here kind of carves into that one, that outputs to my next voice and passes to the next channel of quantizing, and another trigger rhythm carves into that one, and we have this shift register passing down behaviour of that melodic information. So here I'm using Ziggurat with an Audiorate just oscillator sine wave, creating this kind of low resolution, lo-fi, bit crushed and downsampled waveform. Now removing my sequencing and letting this sound drone here, the green trace is the input to this quantizer channel and the yellow trace is the output. And we have both vertical amplitude domain stepping, which would be bit crushing, and also horizontal time and frequency domain downsampling. I don't know the rate that this can actually create a new note, either via a trigger or just self-generating from the slope changing there on the input. But I don't think that really matters. But what's interesting is this is the maximum amount that we can go for, and if we change both the scaling here on the scope and then the rate of the sine coming in, you basically see that with a slower sine, we have more steps here, and as we increase the rate, we have less steps. We can actually get to pretty much a square wave. You can see there we don't have many steps of information per cycle of this sine now. Now we have this kind of wobbly, glitchy square. And it does top out. And all of this you could consider aliasing. Now another thing that I find interesting here is the idea of note wrapping, and I've attenuated this slightly as the range that you can go to on the bottom there's -4 and not -5. This is a typical oscillator plus -5 volt signal, but I've attenuated it before coming in here and before the quantizer, because going under -4 to -5, standard oscillator wave, it would wrap the note back up. If I deliberately change that range, we start note wrapping, and that coupled with this bit crush downsample, kind of lo-fi, low-res digital processing, interesting results. So because this is a fixed rate of kind of downsampling here, if I start volt per octave sequencing this oscillator, we'll have a fixed frequency of stepping there, giving us a different tone per note. And I really like that effect. It kind of amplifies its lo-fi weirdness. So closing this sound down in a VCA, adding an envelope to the VCA, it's turned this basic sine wave into this unique, crunchy, low resolution, digital sounding, or digital looking at least, wave. So the Audiorate adventures continue here, this time with a downsampled digital clock noise type sound, going through a high pass filter here, and a VCA with an envelope. Now opening that up fully here, this is an Audiorate square wave, so an oscillator, standard audio oscillator, and the square is Audiorate triggering the gate input here. There's no inputs, it's triggering a random value. I've set the range just to suit. And we have noise. I can't go any higher than this, so I can't get to a kind of cleaner, white noise-like sound. But as I bring this coarse tuning down, we can see it's these random values that go to create this noise. And that's what noise is, just kind of fast fluctuating random signals. We could sequence the oscillator, so the pitch of the triggering changes, by simply taking this, high passing it, have this nice crackly sound to play with, and then playing that with an envelope in your VCA, you have a range of percussion sounds to play with. So here's another audio patch, this time with a beat as the input, and using this like a kind of bit crush downsample effect. Now you can see the whole patch here other than the sequencing is some 909 samples here being played back. I've split them into a 2-channel VCA just to reduce the level of a loud hi-hat sample, and then one split goes into the scope and is dry here in the mixer. There's a little bit of probability in the rhythms used to trigger the sound, but a basic 909 beat. And then taking this dry, a split copy here on this stacking cable is the input to the quantizer, and that goes to the scope to visualize and is in the mixer. But before it hits the mixer, it's going into my effects here. And I like adding effects to this kind of glitchy, grungy, almost sounds like a kind of enveloped, gargling noise sound rather than those drums, but it's clear that it's following that rhythm. Adding effects to that, and then bringing in that original dry 909 beat, I think works really well. It's a nice layer to have. But even without the effects there, mixing that in against your drum sounds can work well to add some extra punch, noise, and kind of wider harmonic spread around your drum sounds. So here I'm triggering channel 1 without an input, which is giving us a random voltage here, and that's on the scope and being used for the volt per octave signal into my oscillator. But we have a whole additional sequencer built in here that's incredibly simple to use. If I press chain and then select some notes, let's do like basic minor chord here, so C, E flat and G, and then as I press chain again, that gate is cycling through the chain that we've created. Now if you create a chain and you don't like a note, for example, so I'll press chain again here, that clears the previous one. Let's go up a minor scale here. And say I've hit a wrong note there, the F sharp or G flat. If you press offset, that will undo. And I'll keep going, working my way up the scale. And then if we press range, well in chain mode and it's flashing, you can come up an octave. And let's add that C on top of that scale there. So coming back out of chain, we have a basic scale. Now let's do that again. Pressing chain will clear this. Let's say do a minor sort of C minor arpeggio, and then like a G minor inverted arpeggio. And again, I'll deliberately put a wrong note in, press offset to undo that, and maybe go up an octave while I'm doing it. So C, E flat, G. I'm already in the higher octave, so I'll come back down by holding range. Let's do C, E flat, G again. Let's go back up the octave, holding range. D, G, B flat. Back down the octave. D, G, A flat. Oops, wrong note, so offset. And B flat. And as I press chain, you've got some basic arpeggios that cycle round. And if you like this, because it keeps clearing every time you go in and out, I've now lost that chain, you can save it. So let's just do a basic arpeggio again, just 3 notes. If I press save, just save to that first slot. Whatever I do now, say turn chain off, it's random there, or create a new chain even, I can press load, pick the slot where I saved it, and bring it back. So here I've created 4 chains on Ziggurat. The first 3 I used triggered with some probability, in this case not triggered at all, to create some chords here on Ripsaw, and the 4th one is a modulating sequence that plays a bass sound here, plats into the opto mix, tuned quite low here, and that's the green trace. It's just C, G, F, C. But that same bass sequence is split in a multi here into the mod input, and that mod is set to offset for the first 3 channels. Now let's mute the bass, open up Ripsaw into this filter, and if I unmute the triggers that are triggering through those chains, with varying amounts of notes in the pattern and various ranges, I went into chain, added C, E flat, G and B flat, like a minor 7, a C minor 7 chord of information, with the notes jumping up and down in different octaves, and as I say, one might be 4 steps, the other 7 and the other 10. So it's just randomly triggering through those changes. If I remove the actual modulation here, let's go mod, just unassign it, just hear how that's cycling around different intervals within the same kind of C minor 7 chord. Now I can add probability here so these don't change as fast. We can mute that triggering even happening and get that sat on a chord tone that we like. And then as I bring the bass sound back in, let's assign mod to offset on those first 3 channels again. So the bass sound, the bass sequence from the 4th one, let's assign that mod again. So that's transposing that. And that's going to transpose over the available notes set in that scale. Get those triggers happening again. So 4 chains of different lengths, triggered by different rhythms, and one of them transposing the other 3. So having played with triggering this at audio rates or passing audio through it, I wondered what happened if we created chains and we drove them, triggered them from an audio source. And that's exactly what we're doing here. The green tracing cables is a square wave oscillator, just a basic oscillator that I'm volt proctive sequencing. Let's pull out that volt proctive sequence. It's the same trigger to channels 1 and 3 here. I'm using 1 and 3 simply because this stacking cable is quite big and bulky and it's in the way for channels 1 and 2. The blue trace is the first channel output and the yellow trace is the second output. Now muting some low pass gates here in my mixer, if I unmute this channel, this is the actual driving square wave from this oscillator, the green trace and green cables. Muting that, the blue trace, we can see is 3 steps. And the way I've done this is just like all the other chains, but I've done that across a wider range. So if I unmute this here, I have this really gritty 3-step wave. And it taking 3 cycles of triggering, it's like a divide by 3 on the frequency, so we're working with subharmonic intervals here on top of that driving square wave. Now if I do this on a channel I'm not using quickly, say channel 2 here, I turn the chain on, use range, say select a high octave range there and choose the note C, maybe a mid range, the note C again, and a low range and the note C again. And that will then cycle through those octaves, giving that wider range of voltages. If you did this within 1 octave, you'd only have an octave of voltage for your audio, which would simply be very quiet. So again, this is the first output, driven by this sound, and the yellow trace is an octave lower as it's 6 steps long. That's panned hard right here. So I've just pressed chain, done 6 steps of different notes, and just the 2 outputs here from these 2 channels, hard left and right. You can hear this gritty audio just out of the Ziggurat outputs. And down the middle in the mixer, there's that driving square wave too. And because it's an oscillator driving it, if I pitch sequence that oscillator with a 5-step sequence here, these channels are tracking that changing pitch, and giving these subharmonic sounds to work with. Now all this droning sound is patched into different channels of a low pass gate, and even without the sequencing here, if I start adding some probability to how the channels are triggered between the driving pulse from the oscillator and the 2 outputs, the 3-step and the 6-step stepped waveforms there, nice kind of gritty, bouncy, octave-like stereo image. And then driving that core oscillator again with that volt per octave sequence. That's a pitch tracking oscillator driving the triggering of 2 chains, 1 3-step chain, 1 6-step chain. It's a kind of custom stepped waveform oscillator, the Ziggurat. I don't know how to describe it better than that. Hope that's been clear. If it hasn't, leave a comment. Yeah, another fascinating thing to spend more time with, playing around here. So here we'll look at loading and saving sequences. And you can even, and this is nuts, you can even use external volt per octave signals to address and load your settings. And consider that any settings could say be a chain, which would actually be a sequence of notes, which is what I have here, just using a clock to work through a saved chain. That's really incredibly powerful. And loading and saving, before we get to actually doing this via volt per octave, is incredibly simple. But it's worth noting that there's an auto save layer separate to any actual load and save slots. So this is always auto saving what you're doing, and if you power down your system and power it back on, that auto save will load, so you won't lose what you're doing when power cycling the case. But if you actually want to load and save something here, it's incredibly simple. If you press save, you're presented with what would be the black keys here, the flats or sharps on this keyboard interface being your banks, and then what would be the white keys, this row, is simply 7 slots. So if I just press a slot, that's saved instantly and you come back out of that menu. Loading is equally simple. If I press load, let's say go up to the next slot here, so bank 1 to the next slot, instantly loads. And you can hear there's a bit of slew on that one. So it's saving everything here, the slews, the offset, the ranges that you have. And you can hear I just have 7 chains, but they don't have to be changed, they could just be the settings and you're still putting inputs in. That's just not what I'm doing here. So save, select a bank, select a slot, and the same for load. Super simple. And as I say, you have that autosave layer, so anything I do to this, whether it's saved or loaded or not at all, there's always that autosave layer that's active, constantly saving what you're doing, which will recall on power cycling. But as I said earlier, you can use a volt per octave signal to the mod input to actually select your loaded states. And as mine are all chains here, again they don't have to be, but as I have these chains, these sequences of notes loaded, I can use an external volt per octave signal to load a whole sequence here. If I press mod and then load, and I come back out of mod, it's quite nice to see what these notes are doing, I have an external keyboard with a volt per octave output, and that's what's coming into the mod input here. So much like pressing load and working through them, if I press the keys here, the next key is the next slot. So if I just do the same for those first 4 slots, load, that's exactly the same now as the mod being assigned to load. Just loading via volt per octave settings, there's so many patches I want to explore with this, in that it's saving the whole state and not just kind of basic chains as I have done here. That could be incredibly powerful for sequencing your sequences, sequencing your quantizer settings. It's just another kind of like hats off moment to Acid Rain and the design here of Ziggurat. They've done an amazing job. If you've got this far in the video, drop a gate sync down in the comments. Can you see yourself with a Ziggurat? Do you have another quantizer that you like to use? Let us know. Head to patreon.com/DivKid for multiple extended or totally new exclusive patch videos with Ziggurat, and plenty more videos too. And you can join the DivKid Discord community from patreon.com/DivKid too. Thanks for watching, and I'll see you next time. Bye!